Hello everybody. So last time we did volume, which means this time we are doing surface area. So again, before we get into the solids, let's do a little review of the different two-dimensional shapes we see. So very first thing is that our learning target says I will be able to identify solids and use the formula sheet, but this time we're solving for a surface area. Alright, so there's some stuff on here that we actually don't need, so you can just cross off the perimeter part of all of these. So on these two you don't need to find perimeter. We just want to do the area. So our area of a square is s squared. Here we see that the s is 3, so 3 squared, which means that our area is 9 centimeters squared. Pretty easy. Next we have our rectangle, so length times width, 6 and 3. So again, our formula is length times width, which is 6 times 3, which is 18 centimeters squared. Alright, and then last but not least, we've got our circle here. So our area formula is pi r squared. We remember this one, hopefully, from our circles unit. Pi times our radius squared, but I see 6 is this whole length, and I want just half of it. So 6 is actually my diameter here, which means the radius is 6 divided by 2, which is 3. So my radius is 3, so 3 squared right there. So if I leave it in terms of pi, I just have 9 times pi. If I multiply the 9 and the pi, I get 28.3 centimeters squared. Alright, so hopefully that came as an easy review for you. Now let's talk about surface area. So surface area, again, is going to use all these different areas we had up here, but this time we're finding the total area of all sides of a solid. So, like if we did this prism down here, I could use both of these formulas and add up each of these different sides on the prism, but it turns out there's going to be an easier formula for us. But that is what the surface area is. So I always like to think of wrapping paper on a present. So your wrapping paper is actually the surface area of the present. Alright, so let's look at how much wrapping paper is on all of these different solids. So luckily we're only going to look at surface area for just a few of the solids we learned about last class. First up we have that rectangular prism. You're going to see this guy all the time. So our rectangular prism, again, we've got that formula sheet you'll be able to use. So your surface area, the formula is a lot longer than it is for volume, but that's because we have to add up all the areas of all the different sides. So your area is 2 times the length times the width, plus 2 times the length times the height, plus 2 times the width times the height. So our variables here are L is 4, our width is 3, and our height is 2. So now if I plug those in, I have 2 times the length times the width, so 4 and 3, plus 2 times length times height, plus 2 times width times height. So if I simplify that a little bit, multiplying the first 3 gives me 24, plus 2 times 4 times 2 gives me 16, plus 2 times 3 times 2 gives me 12. So my surface area is 52 centimeters squared once I add those up. Alright, our next solid is our cylinder. So your cylinder's surface area, if we look right here, is kind of like the area of each of these circles plus the area of the around part of the cylinder, like where a label would go on a can. So your formula is 2 pi r squared plus 2 pi r h. So our variables here, we've got our radius is 2 and our height is 3. Now I just have to plug it in. So I have 2 times pi times r squared plus 2 times pi times r times h. So 2 pi times 2 times 3. Again, if I want to simplify this a little bit, I get 8 pi plus 12 pi. And then if I just add those and leave my answer in terms of pi, I would get 20 pi as the surface area. Or if I multiply 20 times pi, I get 62.8 feet squared. And that is my surface area. Next we have our sphere again. So your sphere's surface area is a pretty straightforward formula. It's kind of like the area of a circle, but we multiply by 4. So 4 pi r squared. So here my radius is 4. So I just need to plug radius into my formula. So 4 pi times 4 squared. If I multiply those out and leave it in terms of pi, I have 64 pi. If I multiply 64 times pi, I have 201.1 centimeters squared. That's it. All right, just a little bit more on the back, so flip it over. We are going to look at our cone as our last solid here for surface area. So if looking first at this middle problem, my surface area formula for a cone is pi r squared plus pi r L. So L here is not length like it is up in rectangular prism. L is going to be this side measure. So kind of like if you were standing at the top of the cone and slid down the outside. That is the L. It's called the lateral height. So your surface area formula, pi r squared plus pi r L. If we look at our 3 different numbers here, I only have 2 variables, so I have something extra. If I look at the bottom, that's my radius because it's halfway across the circle. We talked about how this slant is the lateral height, or the slant height. So that is L, which means that right here was just our regular height. And you can see that again on your picture here. So this is marked with an L, an R, and an H. So you will have that on your formula sheet. So in this problem, I don't need the H, so I can kind of just ignore that and plug in my radius and my slant height. So plugging those into my formula, I have pi times 20 squared plus pi times 20 times 29. If I simplify that a little bit, I have 400 pi plus 580 pi. And then if I just add those, I end up with 980 pi as the surface area. Or if you multiply out the pi, you have 3078.8 centimeters squared. All right, so now let's look at this cone over here. So again, we have a cone. And I know my formula because I just did it. I only see 2 numbers. So I see the bottom here. I remember that's my radius. But I've got this straight up and down in the middle, which is just my normal height. So I've got the radius is 3. I've got the height, but I don't need that. I need that slant height, and I don't know what this is yet. So first I'm going to have to find that. But if you look at this shape here, so if you see the height, the radius, and this slant height, this pink shape that I'm shading makes a nice right triangle, which we know exactly what to do with. So if you slide your paper this way, let's do a quick intermission of right triangle here. So this right triangle, if I've got 2 sides and I need 1 side, we use our good old Pythagorean theorem, a squared plus b squared equals c squared. So I have 5 squared plus 12 squared equals c squared. 25 plus 144. I'm actually going to go ahead and plug in that L there for c. I add those together, get 169 equals L squared. Take the square root of each side, and you get 13 is L. So that would be a lateral height if this were a cone. So if that's, you don't have to draw this, but if this were the cone, we just had 12, you had the height was 5, and then this part is 13 that you just found. So what we did here, we can now do over here to find that slant height that we don't have. So my triangle here, 3, my radius is the bottom, my height of 4 is the side, and L is what I'm looking for. So I can do 3 squared plus 4 squared equals L squared. And hopefully you've noticed that the L is always going to be the C part of our Pythagorean theorem. So you have 9 plus 16 equals L squared. You get 25 equals L squared, and if you square root each side, 5 is L. Alright, we are almost done. Now that I've got L and radius, I can just plug those in. So pi times my radius squared plus pi times radius times slant height. 3 squared is 9. I'll leave the pi. And then plus 3 times 5 is 15 pi. So if I leave it in terms of pi, 9 plus 15 is good old 24 pi. Or if I multiply that out, I get 75.4 feet squared. All right. Thank you for hanging in with me, guys. Nice job. And move on to the practice.